Hey, it is showtime. Welcome to another rousing adventure of chill skills, Sporlan Tech Talks. Thank you for joining us today. This is a recorded webinar and it will be posted to our site for your viewing enjoyment. That way you can watch it over and over again.
If you're so inclined.
That's right. The topic for this episode is the S3C series case control. This is part one of a multi-part series covering the S3C case control product line. Here's a shameless promotion for the next webinar. I always have trouble with saying here's a shameless, but I pulled it off, I think, okay. Don't you think, John?
I think so.
We will be releasing new episodes of this epic in relatively short order, just like the other big streaming services are doing. In approximately 2 weeks, we will post, wait for it, part two of this series of webinars on the S3C case control, and we will tell you about more fun stuff involving this relatively new product from Sporlan. Now, Sporlan's always here to assist you with your air conditioning and refrigeration flow control needs, whatever they may be. You can reach us by calling the general number for Sporlan headquarters. That's 636-239-1111. This number will provide options to get to customer service or tech support. You can also dial tech support directly at the number provided, or you can shoot them an email, and that's our general tech support line. And of course, we're always here 24/7 at sporlan.com. Hello, I'm Jim Jansen, Senior Application Engineer. That's me on the left. It's kind of irrelevant since we're broadcasting our video images these days. And again, joining me today is John Whithouse. It's my longest running co-host. It's this guy over here. John is a senior principal engineer for the Sporlan division. He's also a published author, consultant, and as I have said many, many times in the past, all around extra smart guy. That's why I got him here with me. All this means John is a real big deal around here. John, thank you for joining us today.
Absolutely.
Might want to say hi or something like that.
Good to be here. Hello, everyone.
And of course, Phyllis is in the room, our communications director. Is that more appropriately marketing communications director? Did I get that right? She tells us what to do and when to do it. And every once in a while, we pay attention to her.
Indeed, we do. Once in a while.
Once in a while. Here's an application of the basic refrigeration cycle in the form of a DX multiplex rack. It looks quite complicated here in this diagram. Really, it's not. Just remember, there's only 4 primary components in every system. You know, compressor, condenser, evaporator, expansion device.
Yep.
Yeah, that's it. Now, today, we're going to be discussing some devices, gadgets that are contained within this area. Primarily, that's what we're going to be doing. Now, the S3C is a standalone case control. Standalone means it can function without being connected to the building's automation system. That's really a neat feature, but that's not all. It can also be connected to the building's automation system. How about that? It's got an open protocol, and it can be connected to the building automation system. That sounds like the Department of Redundancy department there.
Get away.
Or the BAS, if that happens to be beneficial for that particular application. Some people are going to go one way or the other.
Yep.
It can communicate with the BAS via 2 common control methods. John, what are they?
It can communicate over BACnet or Modbus, either one. It's native with both protocols.
And is that Modbus like an old VW Bug with flowers all over it? Or is that some kind of different
You're starting
bus?
to show your age there, Jim. I'm sorry to say. It's a little different than that.
Yeah, okay. Yeah. All right. The 3 S's in the S3C case control system's name stands for safety, service, and security. Let's talk a little bit about those 3 S's. This first, safety. Food safety. That's really critical.
Food temperature safety is actually very critical. It's probably the most critical thing to watch out.
Would you say it's the primary function of the S3C, John?
I would say it is certainly one of the primary functions. Yes.
So it works to protect the product in the case. So maintaining food safety for consumers is a really valuable thing that this control does. Next, there's service. Sometimes you just need to be able to get inside and take a look at things, so to speak. And it's tough to do if it's one of those old black box kind of gadgets, right, John?
Very much.
What happens if the case temperature is too warm or the evaporator doesn't defrost completely, for example? Well, then what happens?
Well, the S3C basically provides a diagnostic system to help the technician tell what's going on with the case.
We could even connect to it and help diagnose problems like that.
Absolutely. We'll get into how we connect to it a little bit later on.
And security. Now, during the development stage of this product, Sporlan interviewed service technicians and facility managers. What did we learn there, John?
Well, we learned that there was a need for a control device to continue to function without the building automation system. So in other words, if that system went down, something happened with the supervisory control over the building, the S3C continues to function and continues to keep the case functioning properly to keep the food cold.
Wow. That'd probably be a really good thing to have happen. The S3C series of controls includes the case control. Now let's do this, John. I'm going to see if I can find a laser pointer in here. It includes the case control, the little display module here, and something called a valve module. All support open protocol communications via, you said it earlier,
BACnet
and
Modbus.
The S3C was designed to facilitate both installation and integration by the refrigerated appliance OEMs. That's a fancy way of saying, the refrigerated case manufacturers and those other
Correct
devices of that ilk. It is also compatible with retrofit applications in existing supermarket refrigeration control installations. Now, when properly set up, the S3C provides automated configuration and network integration. It can provide that standalone feature we talked about, our BAS coordinated control of up to a maximum of 8 refrigerated cases per lineup. And what else can it do, John?
The S3C can manage single or multiple cases, superheat and suction control, and it can also control things like the lights, do defrost control, fans, liquid line solenoids, and anti-sweat heaters as well.
Wow. So in theory, the S3C series control would simplify and shorten the time required to set up new or retrofit installations. Now, let's start talking about each one of these components. Here is the case control. There's a lot of electrical features associated with this device. There's inputs and outputs. Quite a bit of detail on this slide. From an electrical point of view, we've got an external DC power supply, which must be of a certain class. It's class 2 and class 2 rated. There's a specification for a maximum wire length between the power supply and the case control, and that's 400 feet, depending upon the gauge of the wire. I think we specified that at 22 AWG.
Correct. And you think about it, 400 feet is actually quite a long distance. It gets you quite a ways out there, even in a pretty large store.
You wouldn't think you would ever have a need to exceed that, but I guess there's a possibility that might come into play. And we'll talk about in a future episode how to deal with that. Digital inputs, well, you can have dry contact or open collector connections. There's negative reference to be supplied by the case control only. There is an option for an occupancy sensor. We got door switches, service switches. It's user configurable, and we've got analog inputs as well. John, can you tell us a little bit about that?
So there are up to 5 temperature inputs on there. They can handle, the S3C can handle 2K, 3K, and 10K thermistors. So that's selectable in the software. There are Also, auxiliary temperature inputs configurable via software, and also current transformer or CT inputs, CT outputs, 0 to 5 volts DC, measuring from 0 to 50 amps. Pressure transducers as well.
You're starting to trip up like I did.
I am indeed. Pressure ranges up to 150, up to 300, up to 500, and up to 652 psi are available.
There's even a relative humidity and ambient temperature sensor.
Correct.
A lot of things here. We probably have tried to delve into this a little bit too much. And then, of course, there's always the communication details that we show in there as well. Here is the S3C valve module. Now, the valve module is simply an extension of the base controller. It expands the control capabilities of the S3C control system by providing additional input and output if there's a requirement for more complex applications. Let's say you've got more devices you need to terminate on the control, or you have additional evaporators in that refrigerator case.
Right. The only reason you need this is if you run out of input or output capacity on the S3C itself. But as we already just discussed, the S3C itself has quite a bit of capacity itself. So you can look at this as an expansion of the actual.
It's an extension of the actual devices. Yeah, absolutely. Now here, just a few more details on the valve module with respect to if you were to terminate additional electrically actuated, electronically controlled devices like for the control of EEPRs. And it shows the certain position that these dip switches would have to be configured in order to provide for that. And then it also talks about the RS485 connection that we can utilize.
Right.
Here is the display module, or sometimes referred to as the DM. In earlier iterations of this, it was also referred to as the RDM, which meant remote display module.
Correct.
Not really dumb manager like I would prefer.
No, doesn't refer to that at all.
No. Now, it has electrical power supply requirement. You've got to have that same external DC power supply. Again, there's a maximum wire length that comes into play here of 400 feet with 22 gauge. And the display module meets quality operating conditions and storage conditions, as well as compliance with the typical standards, which we will talk a little bit about here. The S3C meets those quality operating conditions and storage conditions, as well as compliance with things like UL and RoHS and FCC and CAN, and the list goes on. Here it details some of the operating constraints of the control itself, temperature and humidity. And you might gather from this that, and it is indeed true, we intend for you to install these control devices outside of the refrigerated space.
Correct.
Something else to keep in mind, they do not have ingress protection rating. So no IP rating.
Right.
And so you shouldn't be going around hosing it down with a garden hose.
Correct. That would probably be a bad idea.
Now, the control and valve modules would typically be installed by the equipment manufacturer, the OEM.
Typically would.
Yeah. But the display module might just ship loose. And if it ships loose to you, that means you're going to have to install it at the job site.
Correct.
Same thing would apply. We don't anticipate that you would install it inside the refrigerated case. Here's an example of the DC power supply. It provides the necessary power for the control components to function. Currently, the S3C product line is supplemented with this convenient walk-in panel. This is pretty cool. We've got all of the required components built into this enclosure. It would be suitable for use with walk-in coolers and freezers. John, what all does it include?
So this panel would include the case control,
That's
valve,
right.
the valve module. Let you point at that.
And And so I've got to find it here. We've got it hidden in here almost. There it is right there. Holy cow, we labeled it.
Right in the middle.
What's the matter with me?
Look at that.
Yeah.
Look at that.
When I say, what's wrong with me, I usually follow up with how much time do you have?
The display module, which of course we can only see the backside of.
Yeah, because what you'd want to be able to close the cover and then see what it's telling you, right? Oh, wow, wouldn't that be useful?
So it would also have the fan breaker and relay, defrost relay, and any other components needed in there.
And you could use it to control discharge air temperature, lights, defrost, fans, and the circuit EPR. Mm-hmm. And for your handy reference, look what we've done here. Look at this thing. What is this?
Actually attached the wiring schematic right inside the door of the panel.
That way you can't lose it.
That's right.
Yeah, I would.
That's right.
I'd tear it up or lose it, one of the two. And then we've also got a parts list here with item numbers for replacement components if you ever would need that. It's all too handy.
Indeed.
Here are some basic installation instructions for the S3C walk-in panel. Note the location of the mounting screw openings there. You could install this panel on the outside wall of the walk-in cooler or freezer. Just don't mount it within the refrigerated space, just like we've said before. Just find a convenient spot where you can get to it, and so you can see things like the display module.
When you think about it, just this whole module, this whole panel set up with the modules in it. What you have to do is just mount this up with 4 screws, connect the wires from the cooler, and you're ready to go.
Wow.
You have the termination there, all the terminations for the wires right up top. It's actually really simple and easy thing to do. It's a way to get a walk-in cooler up and running very quickly.
Well, and just to help you even more, we've made a few specific ones. Mm-hmm. We've got a walk-in panel with electric defrost with the valve module. Look at that. We got it with the electric defrost. We got this version. We got this version. We got 1, 2, 3, 4, 5, 6 of them.
So we support both electric and off-time defrosts on these walk-in cooler panels. With the valve module and without the valve module. So you have a number of different options that you can specify on these to have them tailored just for your specific application.
And we're kind of even telling you how to order them there with an item number, part number, if you will. Now, we have installed fuses for the relay outputs on the S3C. This includes the fans, lights, defrost, and liquid line solenoid valve. And you just look under the front cover of the S3C walk-in panel that you would find there. We've also included the fuse part number here as well. So underneath this cover, I think I might have said walk-in panel. I mean, I meant the cover of the
case control.
Case control.
The control itself, yes.
Case control itself. It's right there. And then also in the valve module, there's also a fuse for that as well. That fuses the solenoid pulse valve. This one, there, as we mentioned, there's the fuse for the fan, fuse for the lights, fuse for the defrost. And then, of course, we've told you here not to go sticking scissors into electrical outlets because we don't want you to get shocked.
That is correct.
Yeah. Here is a list of most all of the sensors and associated part numbers that go along with this device, from temperature probes, transducers, transducer cables, and some miscellaneous things that you might need, like the power supply or a step motor actuator, which would help you to diagnose problems with an electrically actuated valve.
So these cover the different sensors that we discussed earlier on in the presentation.
And there are the part numbers for you.
Part numbers and another view of the different ranges that are available.
Absolutely. Now, what's coming up next here? Wow. We are constantly getting questions. We have a number of, and I meant to mention them here, and I will in a future episode. We've got some professionals that put their heart and soul into answering questions that come in from technicians who are out in the field day and night trying to make all of this work and come together. And they get a lot of the same kind of questions over and over again.
Indeed.
We thought we'd list a few of them here. Here's here's one. I'll go ahead and read the question. It's from Anonymous. Everything looks okay with the electronic controls, but the temperatures are not pulling down. What could be wrong? John, what could be wrong here?
Well, in this case, there are a lot of different things that could be going on. You want to make sure the rack is properly powered up and running at a sufficiently low suction pressure to achieve the desired evaporator coil temperature. You also want to check the operation of the liquid line solenoid. You might want to make sure the correct refrigerant is in the system. That's a big deal.
Yeah.
Make sure that any system service valves, such as ball valves and hand valves, are open. Make sure that the liquid filter dryers are not running high differential pressures.
And if they were, what would that mean?
That would mean that they have done their job and caught a bunch of debris.
And time to change them.
Time to change them. So you don't want any dirty or clogged strainers, and that can certainly be an issue on an initial system startup.
No. I guess what that just goes to say, much of our S3C tech support seems to be dedicated to resolving basic refrigeration system issues and delivering the accompanying resolutions, which is that's part of what we do.
Yep, it is. That's a lot of the questions that team gets, really, is what it comes down to.
Well, here's another really good question from Anonymous. It says, there's some kind of flow control in the liquid line at the inlet of the evaporator. I'm not sure what it is. I'm not sure what it does. John, can you tell us about that?
That's an excellent question. Well, it could be basically one of three things. It could be a thermostatic expansion valve or a TEV.
Yes. What would that do?
It would be used to control superheat at the location of the sensing bulb. The copper cap tube connects the bulb to the refrigerant, connects the bulb to the diaphragm housing or thermostatic element on top of the valve body.
And then over here to the sensing bulb.
Correct.
So we've had some folks, they have a little hard time recognizing this device, and they'll see this copper cap tube and think it's maybe some kind of cable, but it's a conduit for the thermostatic element constituents that are helping to control the valve, tell it what to do so that it can control superheat.
It's nothing but a pressure communication device.
Right. What else could this be?
Well, it could also be an electronic or electric expansion valve. This one we're showing here, is an electrically actuated, electronically controlled stepper valve. And this one actually has a cable attached to the motor assembly.
I guess that's what you'd see here.
That's correct.
Compare and contrast that to the copper cap tube over here.
Well, the copper cap tube on the TEV, like I said, is just a pressure communication device between the bulb and the diaphragm head on the valve. But the cable on the EEV actually provides the means for the controller to operate the valve open and closed via the stepper motor that it's attached to.
What a deal. Now, there's another thing that it could be.
That's correct.
What is that?
An SPW or Sporlan pulse width valve. This is also technically an EEV, but it operates on the same principle as a solenoid valve. So it is.
But it could also control superheat in this application, right?
Yeah, absolutely. It does control superheat in this application. And it just provides pulse width operation. So instead of stepping partially open and closed like a stepper EEV, it is either fully open or fully closed, but in very small time slices.
Got it. Interesting thing that I've noted here, this thermostatic expansion valve right here has a removable strainer assembly.
It does.
Yeah.
It does. Absolutely.
And you can access that if you remove the valve from system pressure, or you isolate it from system pressure. Likewise, over here, this EEV has a similar component.
That's
you
correct.
can remove this inlet strainer, you can clean it, you can replace it, and that's a real good service attribute of these two style of valves.
Yes, it is. Yes, it is. And one other thing I note about the TEV, it is a wireless device.
Oh, sure, you had to say that.
I had to say it.
Oh gosh, the other two aren't.
No, they're not. They're not wireless devices, but the TEV is truly a wireless device.
Oh, another thing, I'm not trying to be funny here at all. This particular valve, you may see it deployed in other applications throughout the system.
That is correct.
Do things other than control superheat.
Yes, that is correct. The EEV is actually applicable across a wide different range of uses.
Oh, here's a question I'm not sure you can handle.
How do you spell S3C?
No.
Well, I'm not 100% sure, but I think it starts with an S.
Okay, let's say that it does. Here's another tough question. There seems to be power to the liquid line solenoid valve, but it just won't work. Again, what could be causing this?
Okay. In that case, first thing we'd want to do is check for a blown fuse on the controller.
Oh, we saw this earlier.
We did. We saw that earlier, and again, that is where those fuses.
So it could be this fuse right here that might be blown, and we've listed the fuse manufacturer and part number.
Correct.
In both instances, and there's also one over here underneath the valve module.
That is correct,
and that could be a culprit in a situation like this.
Indeed. And as always, we just want to caution that you really do want to install the correct amperage of fuse in this. If the correct amperage of fuse is blowing in this on a regular basis, there's another problem somewhere.
Right.
We really need to do some troubleshooting and address that problem. Putting in a larger amperage fuse is not a good idea. Pretty much ever. So.
Yeah. I agree. Well, that's just about the end of this technical presentation. But here's another reminder. It won't be long. We'll have part 2 ready to go.
Not long at all.
And we'll post part 2 of this series of webinars on the S3C control, and we'll tell you about more fun stuff. As soon as we get this version all edited, it'll be out there for you to review and view and look at.
That's correct.
And just eat popcorn and drink sodas.
That's right.
At your heart's content.
If you just can't get enough of Jim and I talking about this stuff, then you can just watch it as many times as you want.
Right. Just a reminder, we're always here to assist you with your air conditioning and refrigeration flow control needs. You can reach us by calling the general number for Sporlan headquarters at 636-239-1111. You can get to customer service or tech support, or you can always shoot us an email. Got the email address listed right up there, SVD Tech Support at Parker.com. We're here 24/7 on the website, Sporlan.com. You can stay connected with us for tech support, product literature, training, product videos, events, all kinds of neat things. And you can follow us at all these different places that we're saying right here. I think that's all that still works.
I think so.
As far as you know. And again, I got to really say a big thank you to our internal team here, both from marketing communications to help us put this together, and the unsung heroes that if you're working in the field on these, you know good well the tech support you're getting from Jim and Pat and who else? Dwayne. Those guys are just flat knocking it out of the park.
Yep.
They're
really very good with this.
They're really good with this. That concludes our webinar for today. Thank you for joining us. We'll see you next time.
Thanks, everyone.